Hello.
Hi, everyone.
Hi guys.
Hello, everybody, and welcome to EnvironMental Podcast.
Yeah, this is our podcast where we investigate different aspects of sustainability. We choose a different topic every month and we go really deep into it.
And this month we've been talking about renewable energy. And today we have a change maker in the room. We have Tom Vocke, who is OBS partner and also works at Lightyear, a solar car company. Thank you for being here, Tom.
Yeah, of course. Yeah.
Yeah.
It's really cool because I think I talk about Tom all the time. And today you don't get to say, who's Tom?
I know. Yeah, typically I'm like, we have to fill in the audience with who these people are, the other cast of characters.
Yeah, I'm right here in the flesh.
In the flesh, my goodness. And I mean, what you work on, Tom, is so innovative and incredible. And I think, can you share a bit more about what you do?
Yeah, sure. So I work at Lightyear, and maybe some people know it because we have been in the States. We have been actually all around, but we are trying to build, or we actually are building, we have a prototype already, a car that runs partially on solar power. And the main goal of that car is to be able to use an electric vehicle everywhere. That's our slogan. Our mission statement is free mobility for everyone, everywhere.
Whoa.
Nice.
So the goal is, because a lot of you guys know Tesla, right? So they are very much focused on setting up charging networks and everything, but they usually, they get in the Netherlands they're great, and in Germany it's great, in the States it's great. If you go outside of those countries, it's a lot less great, and that really limits the potential for electric mobility in those countries. So
why?
Well, yeah, electric car, you have to charge it. So if there's no infrastructure for that, and a large part of the world doesn't have that kind of infrastructure, then the car becomes useless. So you're very used to driving up to a gas station, filling up your car and going, and that's everywhere in the world. There's very little countries where that's not possible. But not so much for electric cars yet.
Yeah, that's a really interesting limitation, right? So the Lightyear prototype it wouldn't require you to kind of stop at those charging stations.
Well, it's like any car. So the more you drive, the more you need to charge. And the charging stations, let's say, are the fastest way to charge an electric car. Any car can be charged from any power socket. That's not really the problem. But a regular car would take a very long time to get to a significant amount of range. You charge range, basically.
Okay.
Yeah. So and our goal is to make a car where typically over normal use you don't need a charging point if your country is sunny. Yeah. That's very roughly the
over normal use.
Yeah. So if I would now drive to France, no way I could do that without charging on the sun. That's impossible.
Right.
But if I would go to work every day, for instance, and my work is, let's say, half an hour away, so then that could be done. Like if you just park the car, it keeps charging itself, and by the time you drive home again, you might have enough energy again to drive yourself back home. And then if you take that throughout the whole year, you maybe need to charge here and there if you have a few bad winter weeks, for instance. Yeah.
I see. Okay, so that the Lightyear car also has a Sure Power, the plug, traditional electric cars too. Okay.
Yeah, you don't see that so much anymore because it takes a lot of time. But our goal is to actually, that's one of our requirements, let's say. So we want to be able to charge a significant amount of range in a certain time of just a standard power plug, because that's available everywhere in the world, and that would open up that car for countries that don't have the infrastructure for, let's say, Tesla.
Yeah. Fast charging stuff.
When the car is driving, is it also collecting power if it's sunny?
Yeah, as long as there's sun on the car, it will charge the battery until it's full. Yeah.
You make it sound so simple. It's so funny.
It's really simple. Yeah. But
I guess
the challenges are, you get very interesting challenges. Like, for instance, what happens with people that want to park the car inside? Then your solar panel becomes absolutely pointless. So we get those questions all the time, right? So what if there is a tree? What if there is a building where you want to park?
Right.
So then it just becomes an electric car. So that is the truth. So you have to park it in the sun.
It has to be in the sun.
But you get very interesting things from that. For instance, we are trying to work out like for instance, Tesla is focusing a lot on autonomous driving. What we're trying to do is say autonomous parking, which is kind of the same thing. But it would be great at some point if you park your car where you go, you get out, and the car finds the best spot to charge itself. So those kind of things are coming.
It's cool. It's a little AI freaky.
Yeah, of course.
Yeah.
Could you put your car under like a grow light? Like
I was doing that too.
Of course, but yeah, that's
But
not.
would it work?
It will work, sure. Yeah, but
Yeah.
that's a stupid way to do it. That
Unless you were growing other stuff and you just have to
if you're growing out of stuff, yeah, but then you should still focus the light on the stuff you're growing. Right? Basically, if you do that, and all the power you put into the car has to first go through a light, which is inefficient, then to a solar panel, which is inefficient, and then so just plug it in. Also for your phone, if anybody's listening, don't wireless charge your phone.
Like, no, don't use one of those.
Really?
You can do it. It's very convenient, but it's just wasting.
Really?
Yeah, wasting energy. Yeah.
I didn't know that.
I actually don't know how those work.
Do you
I don't know how.
Basically, very roughly, it's like a.
Questions with Tom.
Yeah. Don't know. It's like essentially they're a transformer. A transformer is basically you have a alternating current on one side, alternating current on the other side, and there's a magnetic coupling between them. Essentially, it's like that, except you remove the magnetic coupling, so it's just a wireless. So you try to get a phone aligned with one side of a coil that is making the magnetic field, and on the other side, you turn that magnetic field back into current again. But because it's free, there's nothing touching. Things like how well they align and how far they're away from each other, and all that starts to matter. And all the little things that are imperfect will cost you efficiency. So I worked on it for a little while actually, and we got up to about 62%. So that means that 40% of everything you put in your phone is lost.
And when you plug it in directly?
Yeah, it's like 98 or something.
Okay, that's
wow.
It depends a little bit on your USB charger, but with the wireless charging, it's USB charger, wireless charger. So compared to wireless charging, it's like 98, 99%.
Okay.
Yeah. So anyway, a little bit of a tangent, but
no, that's good to know. That's really. I mean, I think that really kind of speaks to how there can be a lot of like potential limitations with how this power is being transmitted, especially if things are happening wirelessly.
Yeah, because you see that a lot. So it's actually a phone doesn't require much power or energy. So, but if you do it every day, and if everybody does it every day, and everybody starts charging wirelessly, there's a huge amount of energy just wasted. And you see things like what happens now is that I worked at a company where they were developing a wireless car charger, and there it really starts to matter because they're like you have the super efficient car, and then all the energy you put in, you just throw half of it away. It's just that's insane. Yeah.
Yeah, just to like have this cool thing, like.
It would be really cool though. You just like drive in, and it's like,
Yeah.
Maybe one day it'll be efficient enough, but
I'm sure it will get better. Yeah.
But then the efficiency of solar panels is something that I'm really interested in because we just read a book called The Carbon Boycott by Samuel Avery. We talked about it last week. And one of the things he said that piqued my interest is how solar is really in its infancy because it hasn't reached, it hasn't had the tech advances or like the money or, the focus on becoming more efficient.
I think the focus on solar is more on getting the cost down than getting the efficiency. So there is some smart people in the past there is a theoretical limit on how efficient you can convert sunlight to electricity, and in what setting. So typical solar panels that go on your roof, it's kind of I don't know the exact numbers by heart, but it's around 30%. So they will never convert more than 30% of the sunlight into electricity.
Wow.
The
Okay.
current concept that you have. So there are some tricks you can do. It's a physical limit. It has to do with how you get photons in there and you want electrons out there, and there's some kind of conversion happening in that solar cell, and there is a physical limit. But you can do all kinds of tricks like layering solar cells and using different solar cells for different parts of the spectrum of the light, and heating concentrating light on a solar cell so that you're still less efficient, but you just take more area of the sun, focus it on a very small cell so that you capture a lot of sunlight, basically. So there's lots of tricks you can do,
Yeah.
but they all cost money. And I think it will get better, obviously. But to give an example, in 2011, I was still studying, and I built my first solar car at the university. We were joining a race in Australia. And at that point, we had cells that were around 25% efficient on our car. And nowadays, so now the solar cars this year is using cells that are maybe 27% efficient. So over 9 years, the mainstream solar cells, they don't get much, they're not getting much better. They get a little better, and everything helps, but the main thing is that it's a lot cheaper, which means that you can start to put them everywhere. And that's the main power for solar, I think, is that it's a very simple, it's a relatively simple device. Yeah. So,
Really?
So the solar panel itself. So for solar energy, you have a couple of things. So you have the solar panel itself, which is basically just solar cells with some glass and some material to make it sturdy. And then you put a lot of
what a solar cell is made out of.
That was what I was going to ask as well. Yeah, solar cell.
A solar cell is basically a silicon wafer. So that's all your electronic chips are made out of. So it's a silicon.
It's like a vanilla wafer, but it's made out of
It's
kind
like
of a plasticky
circle thing, not this big, and they how to explain this? So it's essentially just almost the same as an LED. You wouldn't say so, but so the things that make light, your colorful light strips and all that stuff, LED lights, they're kind of the same thing, except the solar cell is a really big flat LED designed for converting solar energy into electricity.
Yeah.
It's nothing more than a piece of silicon with the right doping of materials in there. And from that, it's a very so a wafer like that is super brittle. It's basically a very thin disc of glass, so you have to protect it somehow. And that's why the panels are like in an aluminum frame and have glass on top and stuff. But it's only protection, and protection from people touching it and the environment breaking stuff. So essentially, the cell itself, you can mass produce them very easily. Contrary to, for instance, wind turbines, they're difficult to install. They're easy to make, but you also need electronics. So that's where where the complexity comes in. Let's say, so the wiring and the electronics that actually make sure that you're always working at an optimum point and convert it to AC for the grid and all that kind of stuff. But so those things you will see, both of them, both the electronics and the solar cells, they will continue to drop in price to such an extent that you can just put them everywhere. So that you already see it. For instance, Tesla has solar roofs where just you're building a solar car and there is solar windows and there is so the goal is to get it so cheap that you can literally put it anywhere.
Why is the price dropping?
That is I guess what you said. So there is a lot of focus on it right now. So things get standardized, the materials get and where initially they were used for other things, they are now specifically acquired for solar cell fabrication. So the price of the materials goes down, the cell design gets more focus on being made cheaply. The process around making solar cells get better and more refined.
Just streamlined.
Streamlined, like mass production is possible.
Cool. Okay. That's good.
And then so that's it's for a lot of people now, at least in more developed countries, it's already very affordable to get solar panels. And like 10 years ago, that was less the case, and 10 years before that, it was definitely not the case. So
totally
it's going in the right direction.
Yeah, but then you have to wonder. Like we've talked about this before, like if it would be possible to put effort into changing the materials so that they don't have to be mined, like the rare earth mines that, I mean, that's not a question I'm asking you or that I just expect you to know the answer to.
Well, so actually changing the materials of which solar cells are made, there are some things happening. So you have different solar cell makeups. Do you guys know these calculators that you used to have
The TI.
Yeah. So they had this little solar cell thingy in it that would charge it.
Yeah.
If I remember correctly, an organic material.
Oh.
But the efficiency is very poor. So there is, and there are people looking into solar paints but in the end, I think it will be very much a trade-off of, you see that a lot in electronics in general, is that it's essentially an electronic component, and the trade-off will be, let's say, efficiency versus the complexity of the materials. So if you want to, it will be very difficult to find a very simple organic recyclable thing that also meets the efficiencies that we're having now.
Right.
I think the main trick will be, because that's one benefit of solar cells, is because they are relatively simple. It's basically the panel itself is basically usually aluminum and glass and the solar cell. It is very easy if you do it right. You should be able to separate those again, and you should get the solar cells out again. So I think the trick will mostly be to get to a process where, if you have that solar cell again, that you can reuse the materials. And that's a challenge, because they are really, how do you say that? They're really, I don't know. I'm not a chemist, but I can imagine it would be quite difficult to separate those materials again once they're a solar cell. Maybe if you can figure something out there, then it doesn't really have to be focused on not mining. You would be able to get quite high grade recyclable material. I don't know if that's
true. And that was something in the book as well, right? Where he was saying that like the panels that are being made now last a really long time. And it seems like the only thing that needs fixing is maybe just those kind of protective elements. And
it's also this. I'm not sure. I can imagine currently recycling of solar cells doesn't really happen. I think, not that I'm aware of, and I'm also not sure if that's even possible. So the question is then, like, silicon is not an issue. Silicon is not a resource that we are in shortage of, let's say. But there are elements in there typically that might get rare at some point, or are already rare elements. So either the trick would be to make the solar cell as simply and abundant as possible, or to find a way to, once you make it, that it is possible to separate the materials again and start over. But that's not my expertise. I don't really know.
Yeah. Well, is it made out of the same stuff that like our phones are made out of? Like when you talk about it being an electric component or electrical, is a solar panel or a solar company competing with the phone company for like raw?
It's the same stuff. Yeah, it's essentially electrical.
Lithium so
it's mainly the silicon, but silicon wafers are used for any kind of electronic component chip that you can think of. But also materials that are in there, they are definitely also used in other components. So they're definitely the same industry. Yeah, they're also made by the same company. So or the same processes anyway. Yeah.
Okay. Yeah. That's interesting.
Yeah. So, but you see it already. So all the panels, you see them arising in roofs. You see them arising in or what do you call it? Like cars, windows, and I think the main thing that people are not so sure of is if it makes sense to make giant fields of solar panels that are otherwise used for something else.
But couldn't we? Do you think we need giant fields of solar panels when we have all of these roofs and like parking lots and infrastructure that's already happening? Yeah. Like oh my gosh, what is it called? It's a company called Solar Gaps that I gave to on a Kickstarter and just a while back. They make blinds.
Yeah.
Like window blinds that have solar that just
I think the biggest challenge there is roofs are a very obvious good place to put solar panels, and that's already happening. But for instance, if you're a company that wants to create a significant amount of energy, you need a lot of surface area, and it's just very easy for businesses to buy a plot of land and fill it with solar panels. A lot less work than, let's say, convince thousands of homeowners to put solar panels on their roof and to be able to put the electronics in their houses and to somehow share the profits and losses and whatever.
I mean, okay, but we need both, right?
Yeah, definitely. Yeah.
Like if we just let these big businesses handle it, and we just say, okay, they're gonna just make a big solar field, over there. What kind of like energy democracy? We're talking a lot about energy democracy right now. Like, what does that mean? And I don't expect you to know the answer to that, but like.
And so that's, I think, one big benefit for solar panels is that I think it's one of the few energy sources that is actually really easy for homeowners and people to get. So if you can be very independent from other energy sources if you want to. You just need a roof facing the right direction, basically, and then it will already cover a lot of your energy use over the year. Yeah. So that's definitely a thing, and that you will see also. It's also kind of necessary, because if we go to electric cars, everybody will want to charge their cars, right? So that's not something our grid. So even in the Netherlands, we have one of the most let's say high quality power grids, because we're a very dense country with quite developed country as well. So we can't support that. If everybody would want to charge their car overnight, then we have a problem. Like our grid can't handle that. So, but it becomes a lot easier for the grid also if a lot of people have local energy creation and storage. So yeah.
Storage, yeah, that was something that I was going to ask about. Yeah, it's like that's sort of the other side of this, right?
Yeah.
What do you know about energy storage?
A lot. Actually, I know quite a bit, because electric cars, we have a battery. It's I think that is an issue that will be solved. We're not there yet. So we have lithium-ion batteries. Everybody knows them.
How good are they, though? I get all of this different information all the time, and some people are super anti-lithium ion, which I think is because lithium, but
so in terms of, from what we know, they're playing around with different types of electrodes for those batteries, and they're typically always based on lithium of some sort, combined with some other metals. It's so far, for the current technology you have, the best that we can come up with. So there is no better alternative in terms of energy density.
Okay.
There's a lot of discussion about how do you package it. Do you make flat cells or do you make cylindrical cells? What shape should they be? What materials should we use for the other electrodes and that kind of stuff? But the same concept, it hasn't really. There's a lot of refining the stuff that we already know, but there's not so much
new stuff
that's close to being deployed. What is happening is, for the grid, you don't want to use that. So it's a very expensive battery. It's very high capacity per space, but for a lot of things, it doesn't really matter. For your phone, it's super important. For an electric car, it's really important. But for a grid, you can literally put it. You have land, right? So you can make really big structures. So the size of the battery is less important than the cost per stored watt hour. So you see already.
Wait, can you say that again? The size?
Yeah, so for your phone, the size is important, right? So you cannot go bigger than this. So here it's very important that your battery can support your phone as long as possible within that space claim.
Yeah.
But for the grid, it's a different story. You can have very big batteries, and the more important part is the cost of those batteries. So the cost per watt hour of storage.
Per watt
hour.
And then you can look at other materials. So stuff that's, you have like salt batteries and all kinds of things happening.
I'm really interested in salt batteries. This is something totally opposite, but I have a friend that reached out that said that in Son, which is I don't know, 15 minutes away from here or something, there's an energy democracy collective that is working with like a microgrid with a salt battery, and I haven't looked into it, but
so I'm not a chemist, so I don't know the details, but from what I do know is that it's a very simple battery, so it's relatively cheap to make, and out of materials that are very abundant. So it's like less focused on getting the energy density as high as possible and using all kinds of rare metals. But and then the goal is to just have enough space to make the battery big enough to support your needs. Yeah. And then you have things like, if everybody has an electric car, to get kind of back on topic. So if you talk about energy democracy, if you would charge everything from a grid, then you would have a central power plant somewhere. And then you would have to support everybody's car being charged from that power plant. So you get a lot of cables going everywhere.
Yeah.
But if you have local energy production and storage, then it can go over lots of, let's say, different local small networks. Let's say you need a lot less infrastructure. One of the things that the company that I spoke to recently is looking into is to see if once everybody has electric cars, people will have different times of leaving or coming home or the usage of the car. So there will be a lot of parked cars. Typically, there will be a lot of cars that leave at night or leave during the day. There will be cars that so what it's kind of going towards is they call it the smart grid, is where you kind of give information to the grid on what your intended use is. So for instance, you would say to your car, like, I want to go tomorrow at 11. And so from here to there, and then the car knows, I need about 60% battery for that. So before that time, I have to have 60% battery. And if your car at that point is 100% full, it could choose to charge another car from the battery that it already has, or it could choose I'm going to wait with charging until the energy consumption as a whole in the neighborhood is not so high, because I only have to leave at noon, so I can wait until the morning and start charging between 8 and noon, and then everybody's already going to work, so that's kind of what it's going towards, that your electric car will be part of the energy grid storage.
Yeah. And you are also, and that's also just another form of energy democracy, because now you are part of the power plant.
Yeah, so when people say there's never going to be enough storage for renewables, that's kind of what it will look like. You will have some cheap big batteries, like salt batteries. I don't know the details where it will actually go, but it will be something like that, which will be in, let's say, areas that are less populated, and then more populated areas, you will have lots of small local storage, but mainly also just lots of electric cars and stuff that can be used for that purpose. So that if you combine that in a smart way, then you have a lot of storage in the system already.
Wow. And it just requires people to be a part of it, where they're communicating their actual power needs to the greater smart grid, I suppose.
Yeah, but what if there's an emergency?
Yeah, I mean, it depends on how you set it up, right? So you can imagine that, let's say the default, for instance, cars would never go below 50%, or you say, I just want to charge it right now, and as fast as possible. So there's lots of things you can do there. What exactly it will look like, and nobody knows yet, of course, but this is what is being worked on right now. Yeah.
Do you think, sitting in this circle, we're obviously comfortable talking about things like energy storage and energy democracy, and but in the larger scheme of things, this is radical. This conversation, it shouldn't be radical. It should be the conversation that we're all having. But because you work in this industry, do you ever come up against somebody like the people saying, we'll never have enough storage? And do you think that that's just because they're thinking through an old lens, or do you think that there's some viability to people being, I guess, anti?
So the main things we hear are there is a portion of anti. People have just in general the tendency to focus on the negative sides of anything. Right, so also for electric cars, what about all the copper? What about all the magnets? What about the batteries? What about it's a valid point, right? So, but if in the return you spend 1/3 of the energy to get somewhere, then you can argue what do you want? If you can make regulations around how products should be constructed, so that, for instance, those batteries can be recycled. So it's not there. It's not 100% there yet. It's being worked on, but in the end, it's very feasible that there is a system where batteries, copper, all that stuff is properly recycled and collected. Whereas you cannot get fossil fuel cars more efficient than they are now. So by default, you will with a fossil fuel car always waste about 70% of the energy that you put into it. So
Oh, I did not.
we're stuck there. Yeah.
Fossil fuel cars.
Interesting. So yeah, so even like regardless of those like nitpicky things, like, well, what are we going to do about the copper? What are we going to do about these other elements? It's like all of that's being worked on, but still base level, like moving in this direction is going to make
that electric car at least has a much lower footprint on the planet than a fossil fuel car, because fossil fuel has to come from somewhere as well. You have to have, well, it depends, of course, where electricity comes from. That's a fair argument that everybody always has. Yeah, but if the grid's not green, then your car is also not green.
That's not the problem that you're solving.
Exactly, that's not the problem that we're solving. We're solving for the fact that we have an option to drive clean, and then somebody else has to solve the problem that we have clean energy, let's say. So
yeah.
Eventually we'll come together. Yeah. And that's also actually part of why we put solar panels on our car, is that you know where your energy is coming from at that point. So if there is nobody else involved, if you don't charge it with a charger, you know that your energy came through your solar panel into the car. So that's about as clean as you can get.
I want to light your car.
Yes.
Oh man.
Babe, can we get a Lightyear car?
All right. Maybe eventually, right?
I need to earn a little bit more money still, but it will be cheap eventually.
Yeah. Well, they'll just give you one because you need it.
Yeah, that's how that works.
It'll work. It'll work great.
Wow. This is pretty crazy. I mean, I guess this might be an interest. I don't know about this question. How likely do you think it is that like more companies start to develop solar cars?
Oh, definitely, it will happen for sure.
Yeah.
So there's already other competitors. So we have already some solar cars hitting the market. We actually also have interest from other car companies to buy our solar panels for their cars, let's say, because the solar panels are typically not curved like ours is. So we can follow basically any shape of the car. So that's going to be a thing. And the question there is also cost. So we get a lot of questions about it actually. It's like, why do you put solar panels on the car? Why don't you just put them on the garage? Yeah, you should do both. That's basically our answer. Like you want to put solar panels everywhere, and you want to make it in such a way that it's exactly
all the surfaces. Yeah.
And
that's awesome.
Yeah.
So your Lightyear has a curved solar panel.
Yes.
What's the benefit of that?
That's only looks. So
it's pretty.
Yeah. Yeah. So actually for a car, so you have a few things if you look at where your energy goes. So our main focus, so people confuse it sometimes. So they get a lot of questions. Why? So what if there is no sun, etc., etc. And then it's just an electric car. So why is our electric car so special? It's because we focus a lot on efficiency. So if you, for every put of energy that you put in, we try to convert as much as that into motion as we can, let's say. And so if you look at what the biggest loss is of a car, you have a few things. So normally for a combustion engine, it's the engine. So there's just already 70% of anything you put in goes out. But otherwise, there is also aerodynamics. So that's where all your energy goes, basically. It's one of the biggest components of energy required for a car's aerodynamics. And you have rolling resistance from your wheels. So if you ask why do you need curved solar panels, it is to make your car aerodynamic. It's very important if you want to be efficient.
Does it change the efficiency of the solar panel?
Yes. Yeah. Because in the end, the solar panel, you have to, the most efficient use of a solar panel is if you capture as much direct sunlight as you can. So you can imagine that if you, I don't know if you can show my hand. So if you would shine directly onto this, let's say with the beam, do I have something that resembles a beam? So say your solar beam comes in and you're facing directly, then all of this sun is converted into energy. But if you're and of course this is over the whole panel, but if you tilt your panel not directly to the sun, now this energy is basically captured by more area of the solar panel. So the total energy coming onto your solar panel is less. So you want to always directly face the sun. And as soon as you curve something, you can already see that the only part of it is directly facing the sun. Yeah. So you don't want to curve a solar panel. It's not ideal, but
In theory, yeah.
look at like the sum of things. You definitely want to curve it because otherwise, A, people won't buy your car, but B, your aerodynamics get horrible.
It would just be like this flat thing on top of like a roof rack.
Cybertruck is a thing.
Yeah.
So
The truck.
maybe one day we can do that. So.
Yeah, it's true.
Yeah.
Oh, that's a cool thing, and that's just on the booty, right? They put it on the Cybertruck.
The Cybertruck doesn't have solar panels, but it's a very flat-edged car.
I thought that it was going to have solar panels on the truck bed.
There was an extension for it, I think.
Yeah, there was something. When is that even happening? Is that happening? I don't even know.
It's still happening. Yeah. Don't know when.
Yeah?
Cybertruck situation?
Yeah. I mean, I haven't seen any yet. I'll fill you in if I see
Yeah, you're
any.
in California, so you're gonna be
They've
one of the first people to see that.
they'd be here, yeah. Huh.
Especially in your part of California, because I feel like it's like truck country, but it's still fucking.
It's impress your neighbors with your car country, yeah.
Yeah.
That's where I'm at, yeah.
It's everywhere.
Yeah.
Wow.
Well,
I feel like I just learned a lot.
yeah, I'm
True to, like, I just kind of sit and ask Tom questions all the time. He's like, save me. But I feel like, yeah, I just learned a bunch of stuff.
Yeah, I'm really interested in this smart grid potential future thing.
Cool. Yeah.
When does that happen?
It's already happening.
Really?
Yeah, it's already happening.
Really?
But it's not. So there is already the option for some cars to put energy back into the grid. So that's already a technical possibility.
Is that something that we can choose on the charging station?
Yeah, but it doesn't. So at the moment, it doesn't happen, right? So there is not. You need a certain. It's possible. So the technical, like the standards are there, the machine, the things there, but there is not, the critical mass is not there. So you need way more people with electric cars before that starts to really make sense.
But you need to this is something we've been looking at and talking about a lot, is when you make big shifts is when to make the big sustainable shifts. When for us it's the house. So if, for instance, if we're going to build a charging port here, we would just set it up right away to eventually be able to be part of a smart grid, right?
So for us, it would be the goal then to make sure that we can at least always charge our car with our own solar panels, for instance. It's not, and obviously, if there is an option to then get the homeowner charging thing that can put energy back into the grid, that would be great.
Yeah.
This is a very basic question, but does distance affect efficiency of electricity?
Yes. So you mean distance from the source to the end?
Yeah.
Yes, but not so much. You have you have your power cables and there's losses in them. Yeah. So it definitely matters, but that losses in electricity are a current squared times the resistance of wherever it goes through.
He's like, here's math.
That's how you want to keep the current low. That's basically the goal. If you can keep the current very low, then the losses are very low. So what they do is they go to very high voltages. So that's why that's why everything says danger, high voltage, blah blah in those cables, because you want the much higher voltages than what you use inside your house to transport it, to keep the transport efficient. Yeah.
I see.
So they transport it high.
Yeah.
And then the blocks.
Yeah, the big transformer houses thingies.
Like the transformer, or even one that's on your computer, transforms it into something that.
Yeah, so that's already 200. That's here it's 230. I think in the States is 120 or something. Yeah, but so that's already much lower. But if you talk about the cables, I think they're around 50,000 volts or something like that, and you have different classes. So you have And they're looking now at going to even higher voltages and there's lots of things looking into how do we even transport so much electricity without having to need so many thick cables. So can we go to higher voltages? Can we do other smart things there? Yeah.
Right.
That scares me.
There's so much like room for innovation in efficient, like in more efficient systems in every step of this, it seems.
I think that means that it's possible.
Oh yeah, and I mean,
it's happening, and it needs to be funded.
Good jobs.
I don't have any. Like I can think about it. I could probably figure out like what's being funded in terms of like cars, solar cars, and electric vehicles, and smart grids, and all this stuff. But like as it relates to like just our overhead power cables and how can we make them more efficient and whether they can.
Yeah.
I would never have thought of that.
Yeah, there's people looking into materials that are superconductors at room temperature. You probably heard there's some talk about that sometimes in the news. That's really
I have
future.
not heard about that.
That's really future music, so it's not going to happen anytime
He's
soon.
like, you've probably heard about this voltage current situation.
Definitely.
No. I ask him
superconductors-
questions until he starts saying math as a response, and then I'm like, thanks.
This is not-
Yeah, that's our limit.
I mean, it might as well be.
Yeah, anyway, that there are people looking into. So for instance, also because between power plants, for instance, typically you also have a lot of so that one can back up another, etc. There's a lot of infrastructure there, and they are looking into making it more efficient. So there are people doing material research, seeing if they can find things that are abundant and still cheap that would have less losses. In
But
transport,
would that mean that we would need to like do a whole like power grid
Upgrade.
system change?
Yeah.
definitely. Yeah.
Do you think that will happen?
Yes.
Do you know when that will happen?
It's already happening. Yeah. So a good example is we have in our house right here just now. Everybody in Netherlands now is transferred to smart meters, for instance. A good example of where it's happening, where you instead of just measuring the sum of the energy, you measure both incoming and outgoing electricity separately. So and also transport that information. Nobody's coming by anymore writing down his number. That information goes directly to the company that controls the grid, and that is for this purpose. That is so that they know where the energy goes and how much they can get back from solar panels in people's houses, and so that they can pay people for the electricity at a fair rate of when they would provide that electricity and all that kind of stuff. So all that information is important to make this happen. This is the first step. So that's the first very tangible step that's already basically affecting everybody that's now
We have a smart meter?
Yeah.
I didn't know that.
Yeah, look in the closet.
Yeah.
Wow. Live action. Smart meter tour. That's interesting. I actually didn't know the purpose of a smart meter specifically, other than to like track usage, I guess, but I didn't really think of it as a way of like.
No, the biggest reason why that is there is so that the power company, it's to track usage obviously, but so that the power company has information on what's happening on the grid. No, the previous they didn't know anything. They only know when they come by how much energy you use. That's it. Yeah.
Right. Yeah. Yeah. People were kind of afraid of smart meters because it's another way.
There's risk. So people like if they hack it, then they might know when you're not home and stuff like that. So
Hack it.
Right. Stuff like
hack
that.
a smart meter?
No, I don't.
Okay.
No.
Wow. So there's a ton of innovation happening in this particular field. Do you?
From now, things will look.
I mean, 10 years
Yeah.
from now have to look totally different, right?
Right. Yeah, that's what I was just gonna ask. Like, do you think will it be possible in 10 years to like? Or what do you think is possible?
Electric cars obviously have downsides, right? So electric engines are 100% the future. So we're going away from combustion engines simply because they're inefficient for
Yeah.
cars. So for big ships and stuff, it's a bit more difficult. But cars are going to be electric, so you can. But the way that like now we're talking about charging and batteries and that kind of stuff, which is now what everybody's focusing towards. But it's not unthinkable that there is a better solution where you, I don't know, tank a liquid that can be converted into electricity. So hydrogen is an example. That's
That's what that book was saying too.
But there's many other. There's a company on the campus where I work that focuses on lactic acid. Is that the way? I'm not sure what the English word is, but
What's the Dutch word?
Can you say it again? Sorry,
I think it is lactic acid.
Yeah.
I didn't hear it.
Lactic acid.
Oh,
Sure,
that's a skincare ingredient, but okay.
Basically,
Cool.
the idea is that
So is petroleum.
True.
it's basically hydrogen, except in the form of another liquid, so acid in this case, so that it's not dangerous to fuel up your car that way.
It's
So-
malic acid. You
Could
think.
be. I don't know.
Lactic. I
But
think it's.
lactic sounds wrong, but
I think it might be malic.
anyway, the idea behind
Which
it
is
is that
also a
you
skincare
get an
ingredient.
inert liquid, like so that it doesn't burn and it doesn't require high pressure gas storage and that kind of stuff. And as soon as you want to use it in your car, there is a system to break it down into hydrogen and carbon dioxide again, and then the
Yeah.
carbon dioxide is first removed from the air and then released back into the air. So that's, for instance, one example of what people are also looking into.
Wow.
Is like is the battery the best way to power the electric engine?
Yeah.
Mhm.
But then we'll see. Maybe that
Is
will.
that a combustion engine still?
No, combustion engines will go away for cars for sure.
Yeah, but if something is making and breaking hydrocarbons, is that not a combustion engine?
No, combustion is literally exploding a burnable substance.
Oh.
Yeah.
Yeah, you're
Okay.
So that's not happening. But there is. I think you could call it a fuel cell, so people will call it. So there is fuel,
Fuel cell.
and the fuel cell converts that fuel into electricity and waste. Let's say waste can be water also. Let's say yeah. So
Cool.
Wow.
that's also, so there's a lot of people don't really know yet where that exactly will go, and especially so for cars it's getting relatively clear now that for now, at least for the foreseeable future, it will be batteries for sure.
Mhm.
But for instance, for ships and for airplanes and for that's a bit more
Yeah.
up for grabs still on how we're going to solve that one.
Yeah.
I'm curious. So there's so many different people working on very specific things. How do we get them to communicate together? Like how can like how do they communicate? Like how do you know who these
So
other
for instance, for what I see, for instance, there's lots of conferences happening specifically
okay.
on topic of mobility.
I want to go to work. I want to go to work.
So we have to check up on like what are the newest things happening in our field. So you have conferences specific to green mobility and mobility in general, and you have and the same goes for basically any topic where engineering is required, and probably also non-engineering. There's always
Yeah.
within the field, people are always talking.
Cool. Okay.
The issue is more how do you. Most of those things require very significant change.
Yeah.
So everybody wants to be sure that it's the right thing before it's like very widely put out.
Yeah.
And now you're seeing already that since there are a couple of big backers of the charging infrastructure and that everybody's going towards batteries at this point. But it could be that at some point there is another technology, for instance, the acid or thing that finally catches on a little bit and it gets the right traction, and then all of a sudden everybody puts that's
Yeah.
unclear. But communication is not the issue. Everybody is well aware of what's happening. Yeah.
Well,
Exactly.
I think also just as a rider with that is like within the industry, people communicate.
Yeah.
What about communicating like between industries or into this like mainstream space? It's weird to think because our whole lives are in this like sustainability industry, but there are billions of people that have no information, no access to information, no like community focus, and no plan for a transition. Like we are lucky enough to be able to make a plan to transition.
Mhm.
But like, what about how do we make sure that we are communicating with a plan outwardly?
Yeah, that's your guys' expertise.
Yeah, that's what
Yeah. Yeah.
that question, and then being like, oh,
It's
yeah.
marketing.
But I will
That's
say
what
that
we
I think right now it's very difficult because there's so much happening that even if you are willing to look it up, you get so much information that you have no idea what's real and what's actually happening and what's
and
not.
the math.
So, but I mean, in the end, it will be economics anyway.
Yeah.
So at some point, like now, electric cars are getting affordable. So more and more people have them. More and more people will see their neighbor driving an electric car and say, "Hey, can I have a try?" Blah blah blah. There is now electric cars here, Amber. That can be shared, like Green Wheels used to be, and so there's like,
Do you see that anywhere? It's probably not called Amber, but it's like cars that you can rent. You know, like the electric scooters.
Yeah.
Electric cars that you can rent.
There was a ton in San Francisco. Like, yeah, cars you can rent by the hour. It wasn't specific to a type of car or anything like that, but I haven't seen it in my area, but it's not a densely populated area, so yeah.
Yeah.
electric cars, if they're affordable, they'll sell themselves. They're very nice to do.
Yeah.
Combustion engines anyway. So it's
Can we try one?
yeah. Sure.
But yeah, that's a good point that like once those early adopters kind of like who are connected to the industry perhaps start kind of bringing these technologies into their home and into their communities, and it will pique people's interest, and then as it becomes more and more popular, it gets more and more affordable, and then more and more people can.
You see the same with, so I have a colleague, you see the same with heat pumps, for instance. So how do you heat your house without gas and fossil fuels? So the heat pumps are an important part of that. Nobody has one yet, so it's very new.
We're gonna have one.
Exactly. So there are some people, like I have a colleague that has one, so I visited him just to see like what is it like? Does it work that people say it, and do you like it? Is there, how much did it cost? So that will happen, but it's it takes time.
It takes time. Yeah.
There's also no point in replacing things that are still working fine.
Right.
That's also
Very true.
So
right. That's a really important one. I think that we also agree with. Like we talk about it all the time. Don't just get rid of all your stuff to choose a sustainable thing, because that's not sustainable.
Right.
But it is within an ideology that we are living in, right? Like
Overconsumption.
yeah.
Newest technology, newest thing, shiny object syndrome. Yeah.
Yeah.
Mm-hmm.
Yes. So
yeah.
Fascinating. Gosh. Well, I guess if folks are interested, where can they find out more about Lightyear? Or
if you go to the website, just lightyear.one.
.one.
Okay. ONE. Yeah, that's you'll find most of the info that you can want to find. Yeah.
Yeah. And on Instagram, they're just Lightyear, I think.
Yeah, but all our channels are also listed there, and so
yeah.
Awesome.
Yeah, and if you see us around, so I think there is some interesting stuff happening. Just share and like.
Good job.
Yeah. Well, cool. Okay. Well, yeah. Thank you, Tom, for letting us pick your brain a bit.
Yeah, of course.
Yeah.
Sitting with us.
Hope I brought you some new topics to look into for potential next podcast.
Yeah, we are still trying to figure out what we're going to talk about next month. So I'm definitely interested in
salt batteries or smart grid or
yeah.
That's wild. Yeah. But I think that this has definitely given us a better perspective for like what's possible for the future, what's happening already, and the kind of real application of the transition to renewable energy. And I think that was the goal. So thank you.
That was the goal.
Yeah. Awesome.
Thank you.
All right. Thanks for watching, everybody, and we will see you next time.
Bye.